Buckle up. Here we go. We're going to do some multiple regression on the study 2 data. So welcome. If you're watching this, I hope this will be helpful to you. Just a word of advice. This code does presume that you've already looked at the data, that you've taken a look at the frequency distributions to get a sense of interest in reducing meat consumption, that you've calculated some descriptive statistics, that you've already done the null hypothesis significance testing for the direct replication that involves running a t-test and computing the effect size in our new study 2 sample. If you haven't done that, please go do that. That's what you should do first. In the meantime, what we're going to do now is, presuming that you've done that, is move forward. So I am going to go ahead over here into our studio, and this will look familiar to you at this point. Remember that I am going to be crafting a script, so I'll go up to here to File, New File, R Script, and I'm going to go ahead and start with a blank slate. You'll also know that there is a script here called 02 underscore study 2 underscore data underscore analysis underscore regression.r, and in fact that has everything in it that we're about to do. But I'm going to show you how to build this script basically from scratch so that you can understand what's happening and why. And I think as a first step, I will go ahead and switch to a view that allows you to see the script a little bit better. So right now it's just a blank page, but what we want to do as a starting point is load the libraries that we're going to be using. So we're going to be using 2 libraries that I've already installed in this RStudio Cloud project. One is called JTools, and the other is called Interactions. And with that, we're all set to go ahead and read in the study 2 data. And the data file is actually in the file section of this RStudio project. So all we need to do is call it something like data, and then tell RStudio what command to use to bring that file in. We've used this command before, so it will seem familiar to you. I'm going to use reads.csv, open parentheses, and then in quotes say the name of the file, which is 02 underscore study 2 underscore data underscore 4. Oh, sorry. Back up. Study 2 underscore data underscore 4 underscore analysis dot CSV. And then I will go ahead and hit Control Enter on that line to run the command. And when I do that, you'll see that we have 42 observations, which is something that's only visible if I actually show you the full screen so that you can see in the environment. We now have a data object with 492 observations, which is what we were expecting. The reason we were expecting that is even though we collected data from, actually it turned out to be 551, a bunch of people were vegetarians and some indicated that they had participated before, and one was outside the US, and I'm sort of forgetting all the reasons, but there were, I think, a total of around 59 observations that we dropped. And that's what leaves us with a total now of 492 observations. So going back to the script, I've read in the data, and now actually I'm going to do something that is going to strike you as heretical, but I'm going to do it anyway. And that is I'm going to remove participants from the control condition. We're only doing this for now. We're going to focus on the direct replication, which involves only the dynamic and the static conditions. So to eliminate people in the control condition, I want to use the subset command. And with the subset command, I need to tell it, well, what data file are we going to take a subset from? And that is the object called data. And on what basis are we going to form that subset? Well, what we want to do is indicate or remove anybody who has a value of control. So we want to save the people that are not equal to control. And the way to do the not is to use the exclamation mark. So this command should take us down to, in the range of 300 something observations. I'm going to run this command with Control Enter. And yeah, now you can see, if I go back to full screen so you can see the environment, we have 318 observations left after removing people in the control condition. Okay, great. Okay, now, and also just word to the wise, we're not going to forget about the control condition forever. It's only for now. So that's cool. Let's now get to the real action, which is to say, let's get to the action whereby we're going to run a multiple regression. And the goal of this multiple regression is to see to what extent there is any evidence that dynamic norms increase interest in reducing meat consumption compared to static norms when controlling for another variable that we believe is probably associated with interest in reducing meat consumption. I'm going to focus for this example on political orientation, which is a variable called ideology. You are going to instead focus on a different variable. That is the variable that your group created. Okay. So having said that, I'm going to use ideology, and we're going to set up a multiple regression so that we can do that. Now, I'm also going to pause this because I just realized something, which is I actually intended to not analyze the full data set. I want to be using a subset of 100 people rather than analyzing the full data set so that you can discover the actual values on your own. So I am going to pause this. I'll be right back. Hang on to your hats in a moment. All right, we're ready to continue. I now have gone ahead and repeated the same analysis steps that I've already showed you, but this time I read in the data file that only has 100 cases. And so now we're working with a file after removing the control condition that has 68 observations. And now, as promised before, we're going to go ahead with the running of the multiple regression. So first of all, let's actually make it so that the output of the regression gives us a little bit more precision than we were getting before. When we did this before, we were getting only 2 digits beyond the decimal. And actually, I think it's useful to be able to see 3 digits beyond the decimal when we are thinking about and reporting p-values. So the first thing we're going to do is, in preparation for running this regression, is updating the digits using the sum function. Okay, so let's set the default for the sum function to 3 digits beyond the decimal. And we'll use a function called setSumDefaults, which it's handily already filling out for us. And we'll say digits equals 3. And just as easy as that, we'll now get to see multiple regression output that shows 3 digits beyond the decimal. So I'm going to go ahead and hit Control Enter to run that. And the next thing we want to do is further prepare for this regression. And what we need to do, as you might remember, is to code norm conditions so that it's appropriate for this multiple regression analysis. And we're going to do binary coding, and we're going to set it so that we're creating a new variable called dynamic. And dynamic is going to take a value of 1 for everybody in the dynamic condition, where condition label equals dynamic. And once we've set that, we're going to go ahead and say, let's make that a 1. And what this will do is, for everybody who has dynamic as their condition label for that column in the data object, we'll create a value of 1 and a new column called dynamic in the data object, which has a value of 1. I think I just misspoke, but I hope you followed that anyway. I'm not going to re-record that. And here we go. We're going to do the same thing, but this time we need to make sure that everybody who is in the static condition has instead a value of 0. This is our comparison condition for the contrast between dynamic and static. And by running these 2 codes, we will have created this new column called dynamic. It is a predictor of interest in our multiple regression. And in fact, I think to show you that, I will go ahead and go back to full screen here so that you can see when I open up the data object and show you what's what. If I scroll all the way over to the right in the data object, we now have a new column called dynamic. It's filled with zeros and ones, and those zeros and ones correspond to whether people are in the static for zero or dynamic condition. So there we go. Okay, so I'm going to close that and continue here. After binary coding the norm condition, the next thing we want to do is also handle ideology. Okay. For many reasons, we are going to do something called mean centering. And I am not going to explain in great detail why that is, but you will find in the script that I created, there are a couple of handy references so that you can understand why it is that we're going to create a new variable that is a mean-centered version of the political orientation variable called ideology. Mean center political orientation is what I'm writing in the comment. And what we're going to do is create in the data object a new variable called ideology C for centered. And what we're going to do is use the scale function to center ideology. So we're going to use scale, open parentheses. We're going to say what we want to scale is the ideology variable. And there are two things we need to set. One is, do we want to center it? And the answer is yes. So we'll say true, center equals true. And the other question is, do we want to scale it? Which means do we want to standardize it? And actually for this one, we'll go false. We want to center this so that people who have a value that is the mean across everybody will have a value of 0, and then scores above the mean will count up by units according to the original measure. So by units of 1, because the original measure ranged from 1 to 7. And anybody below the mean will have values of also units of 1, but they will count down. They'll be negative values, -1, -2, -3, and so forth. Okay, so having set up that command, I can go ahead and hit Control Enter and run it. And now we have in the data object a variable called ideology C, which is the centered version of political orientation. And it has some handy benefits to do that. Again, I think I won't explain them for the sake of time. And I will, in fact, go ahead and paste in a couple of references just so that you can kind of check them out. These references are also available in the script that I wrote, but I will paste them here so that you have them. Great explanation about why we might want a mean center political orientation, and then a nice follow-up as well. Okay, great. So I think we're getting there. I'm using the variable ideology that's centered as if it were my group's variable. You, on the other hand, are going to code, you're going to create the code to recenter your lab group's variable. Well, actually, you're not going to create the code. I mean, you could create the code. You absolutely could. You could follow exactly the model that I just showed you. But you'll see in the script, I have already created the code to recenter all of the different group variables. So if you have any difficulties with that, you will be able to just grab the correct row from the script that I wrote. Okay, great. So that's enough preparation. Let's get to the multiple regression action. So we want to run a multiple regression to test to what extent the norm condition manipulation impacts interest in reducing meat consumption when controlling for, in this case, political orientation. We're going to use that centered variable to control for political orientation. And it's actually pretty easy to create the code that runs a multiple regression. So I'm going to create an example model. I'm just going to call it example. Why not? And we're going to use the linear model function for multiple regression. We used this before. Let me just actually give a little space here. We used this before during lecture, so this may seem familiar to you. The linear model is the LM function is what we use to run a linear regression model. First, we need to specify our criterion variable, which is called interest meet. And we want to look at interest meet as a function of two things. One is the dynamic predictor that we created. It's binary coded, 1 for dynamic and 0 for static. And we also want to see in this model, what's the impact of ideology centered. Now I'm going to put ideology centered in here using a star, which I'll explain in a moment. But first, let's go ahead and add in ideology C. And we're going to need to tell our studio what data file to use. So we'll say data equals data because we're going to use the data object. Now, why did I put a star here? Well, this model assumes, by running this model, what I'm assuming is three things, actually. I'm assuming that dynamic norms might increase interest in reducing meat consumption compared to static norms. That's this piece. I'm also assuming that political orientation, that people who are more politically conservative will report less interest in reducing meat consumption. That would be consistent with what we found before. And I'm assuming a third thing, which is that political orientation might moderate the effect of the norm condition on interest in reducing meat consumption. You read about moderators in the chapter about multivariate correlation. This is our first foray into thinking about moderators in some detail. So just know that that's exactly what we're doing. And it's also not something we're going to spend a ton of time on at this moment, because we'll actually have a week of class devoted to something called factorial designs. And thinking about interactions will be a key piece of what we do in that class. So suffice to say that for now, we're looking at the impact of dynamic norms versus static norms, the association between political orientation and interest in reducing meat consumption, and to what extent there is a moderated relationship that affects interest in reducing meat consumption. Okay, so that's it. That's all I have to do. And now to run this command, I'm just going to go ahead and put the cursor on this line here, hit Control Enter, and I now have an object that's called example. And that object has the regression results in it, but it's not very helpful to open it up and just look at it. So let me just go full screen here so you can see that there's this example object. That looks like kind of a mess. So what we're going to use is a function from the JTools package called sum, S-U-M-M, in order to summarize the example model. So sum, S-U-M-M, and then we're just going to put in there the object called example, which is our linear regression model. And that's it. All we need to do now is run it, and then we'll be able to see the results of this regression in the console. So I'm going to go ahead and hit Control Enter, and boom, there it is. You can see in the console. And I think to make it a little easier to see, I will go ahead and zoom in on that console. And having done so, you can see a few things. First of all, the sum function is telling us there are 68 observations, that the dependent variable is interest meet, that we've run what's called an OLS linear regression. It's giving us some F statistics, and it's telling us the amount of variance explained in interest in reducing meat consumption, which is 12%. That's what this R-square value is. And it's also giving us a bunch of information about the associations between each of the three predictors that we told that we were interested in and interest in reducing meat consumption. Okay, first of all, we have the dynamic predictor here. The dynamic predictor, of course, is the predictor that's getting at the manipulation of norm condition. This value is the estimate. It's the B value, minus 0.092 in this sample of 68 people. And the T value associated with that B is minus 0.209, which is a very small value, and consequently, it has a p-value that's pretty large, 0.835. So in this subsample of only 68 people, there is no impact of norm condition on interest in reducing meat consumption. Okay, that's one piece of information. A second piece of information is here. The second, well, actually, I guess it's the third row, is the row that gets at the association between political orientation and interest in reducing meat consumption. And that's the centered variable ideology C. We have a B value of minus 0.204. That B is associated with a T value of minus 0.951. This P value here of 0.345, again, is pretty large. It's bigger than the alpha threshold that we are going to observe, which is a two-tailed alpha of 0.05. And so ideology is also not statistically significantly associated with interest in reducing meat consumption in this sample of 68 people. That p-value is larger than our alpha threshold cutoff. Finally, we have this row here that says dynamic : ideology C. This is the row that gets at whether or not there is an interaction such that the impact of norm condition might depend on people's political orientation, their self-reported identity with respect to liberalism to conservatism. And in this case, in this sample of 68 people, the B is minus 0.308. It has a t-value of minus 1.10, which is also not statistically significant. This p-value of 0.277 is larger than 0.05. So we can't reject the null hypothesis for that one either. So in this small sample, we have A, no evidence to suggest that norm condition has an impact on interest in reducing meat consumption, certainly not in the hypothesized direction. We also have no evidence that political orientation is negatively associated with interest in reducing meat consumption, which is something that we saw in study 1. That association is not statistically significant. And finally, we have no evidence to suggest that the effective norm condition depends on ideology. That interaction term is also not statistically significant. Another thing to note when it comes to these regression results is that all of these associations are unique associations. And what that means is that these associations, these B values, otherwise known as these estimates here in this regression, reflect the association between each predictor and the criterion variable, interest in reducing meat consumption, when controlling for the other predictors in the model. So this estimate for the impact of dynamic versus static norms on interest in reducing meat consumption of minus 0.092 is the value you get at a constant level of ideology and at a constant level for the interaction between the dynamic predictor and ideology. So it's really important to remember that when you're interpreting regression coefficients, that for each coefficient, you're looking at the unique association between that predictor and the criterion variable, controlling for or taking into account all the other variables in the model. So we have learned a lot about the associations between these variables and interest in reducing meat consumption. However, it's a little hard to kind of figure out what it all means without visualizing it. So let's go ahead and run some code that will help us visualize the regression results that we just obtained. Now, for that, what we're going to use is a function in the interactions package. And let me go ahead and show you the script again so we can start typing this out. Let's visualize the regression results. And like I said, we're going to use a function from the interactions package. It's called interact plot. And for interact plot, we're going to do a bunch of things. And I am going to, for the sake of time, cheat and copy stuff from a script that I have off here to the side. That'll just make this go a little bit more quickly. As you see, there's a number of rows here in this command. So I'm going to just go ahead and paste it in and then walk you through it. Okay, great. So here we go. We're going to use interact plot to plot the example regression model that I've just run and showed you. We're telling this command that our predictor here is ideology C, which is political orientation, that we're thinking about the dynamic predictor, which indicates dynamic versus static, as a moderator variable. We are giving it, we're making sure that we have some helpful labels so that when we look at the graph, we'll know what we're seeing. So we have an X label, liberal to conservative political orientation, in parentheses mean centered, just to make sure that people understand what they're seeing when they look at the numbers. Same thing for the Y label, although in this case, we're calling it interest in reducing meat consumption. There are a couple rows here that also are ways to indicate helpful information for the viewer. One is we want to say, well, what is in the legend? Well, what's going to be in the legend, as you will see, is norm condition. And what's in that norm condition are two different conditions, as you know, static and dynamic. And that's what this mod x.labels command does. We're telling it we want to see all the individual data points. So we're saying that's true. I am also adding a command here to make sure that we're showing the output in the colors that we were using before in the t-test, just to sort of keep that theme going, help anybody who's familiar with the analyses we've been running keep track of what's what. There are a couple of commands here that I'm not going to talk about. I do want to mention, though, that we're using this jitter subcommand, and that's because we want to make sure that when we show all the different points from the plot here, from plot.points equals true, that we let them sort of be randomly spaced out a little bit. Otherwise, they'd all be overlapping on one another, and it would be difficult to see all the different individual participants who we are graphing. Okay, and I think that's all I'll say. I'm going to go ahead and run this command in the usual way, hitting Control Enter. Oh, it didn't like that. There's an extra parenthesis. There we go. Let's try that again. All right, and now I've successfully run it. I'm going to go ahead and zoom in on the plots window so that you can see the plot that emerged. Okay, so we have on the x-axis political orientation, liberal to conservative political orientation. It's mean centered. So this value here of 0 is the mean for political orientation. And you can see actually that because there are 7 values possible for political orientation, it ranges from 1 to 7, that it's pretty easy to see how those values of 1, 2, 3, 4, 5, 6, 7 map on to these mean-centered values. So a mean, it looks like our mean is close to a value of 3, maybe just slightly below it, because this 0 is under the place where all the 3s are. So hopefully that makes sense. On the y-axis, we have interest in reducing meat consumption, and we have 2 different lines with 95% confidence intervals, or confidence bands, I should say, that are surrounding them. The green line represents the association between political orientation and interest in reducing meat consumption for people who are in the dynamic condition. And the orange dotted line represents the association between liberal to conservative political orientation and interest in reducing meat consumption for people in the static condition. And as you can see, the slopes here are not all that extreme. There's not much variation that can be explained by political orientation on the one hand, and also these 2 lines are pretty close to overlapping, especially when you consider the degree of uncertainty that's surrounding all of the different predictions that this model is making. And the uncertainty is captured by these confidence bands. Like, for example, here at a value of, let's see, it would be a value of about 6. Actually, these 3 people here have a value of 6. You can see that there's a lot of uncertainty around the estimate of what this model expects people to, who have a value of 6 for political orientation. There's uncertainty about how much we expect them to have interest in reducing meat consumption. We might expect values ranging from, let's see, at a minimum, maybe a value of just under 2, all the way up to a value of maybe 4.5 or 5. That's a pretty wide range. So in any case, the bottom line, as you can see in this figure, that we're not seeing a ton of evidence for an association between the variables that we were looking at in the multiple regression. So the values we obtained from the model that we ran, I'm going to go back to the console here and just scroll up so we can see it, are sort of consistent with what we're seeing in the plot. There's not a lot of evidence for associations between these variables and interest in reducing meat consumption in this subsample of 68 people. So that's a really important thing to keep on mentioning, because this is definitely not the final word. When you run these analyses in lab, you will see many more observations, and I can't wait for you to discover what there is to learn about associations between your group's variable and interest in reducing meat consumption, and how that might impact or not the impact of norm condition on interest in reducing meat consumption. So I think that's all I wanted to talk about and tell you. I hope this is helpful. As always, if you have questions, you can hit me up on Piazza. I'm happy to answer them. And in the meantime, I guess I will bid you adieu and wish you well as you move on and do these analyses yourselves. All right, take care. Bye now. Wait, stop press. I forgot something. Really important. And I think I forgot this before too, but not this time. All right, there's something you need to do critically after you build a script and run it and spend a lot of time on something like that, and that is save it. I didn't save the script. All right, so I'm zooming in on the script view. You can see that I built this lovely script, and I would like to make sure that I can use this again in the future. So I'm going to make sure that I click the little save icon, and I'm going to call this temp.r. Now you're going to name yours something a little bit more informative than that, but I'm about to immediately delete this after I finish this recording. So that's why I'm calling it temp.r. But once I do that, I will save it. It's available to me now in the files section of R, which you can see over here on the right. And having done that, it is now safe to log off and say goodbye and say that we're done. Phew. All right. Bye.